this computer. All right, so I'm going to go ahead and do this first review for you guys so that you guys, and I'll go ahead and record this so that you guys have the, access to this later. This is test review, and I didn't put this on the paper, but it's test review number 1. Okay, again, I'm going to give you guys 2 reviews. They look just like this, right? The second review is going to be like this, but maybe with some different numbers. The next, and then finally, the test that's on Thursday is going to be the exact same thing, except I'm going to change the title, change the numbers. All right. So if you guys don't, if you guys don't know how to do the test, that's your doing, not mine. But either way, so over here it says, what is the ratio used to solve for the following trigonometric ratios? Honestly, when it comes to this, the only thing that I wanted you to do here was remember that phrase, right? Who remembers the phrase? SOHCAHTOA. So it's going to be SOHCAHTOA, right? So the only thing I want you to do for this first part, and this is actually going to be on the test. I'm not going to change this on the test. You have to remember that sine of x is equal to opposite over hypotenuse. Cosine of x is adjacent over hypotenuse, and tangent of x is opposite over adjacent. All right, there you go. You already just got yourself 5% on the test. Look at that. And all you had to remember was remember the phrase, and all you had to do was write it down. All right. Now for this one, it says use your calculator to find the following values and round to the nearest 100. I just want you to practice putting things in your calculator. Isn't that easy? Right? So all I got to do, just practice using your calculator. If I want to take the sine of 25, first of all, make sure that your calculator is set to degree mode. Okay? And if you're not sure with these calculators, you just have to press the degree button until it says DEG up at the top. So either way, if I want to take the sine of 25 degrees, I'm going to go ahead and first type in the angle, then press the sine button. And voila, we have 0.4 to, what did he say? To the nearest 100. So you guys remember how many decimal places that is? 2 decimal places. Good. So if I rounded this to 2 decimal places, that's 0.42. 0.42. All right. Same thing with these other ones. If I do the cosine of 53 degrees, I'm going to first type in the angle 53. Then press the cosine button, and I have 0.60. I'm going to do tangent of 81, so I do 81, then press the tangent button. All right, that is 6.31. Did I do that correctly? 81, tangent, yeah. So 6.31. Okay. And then, of course, we're going to do the same thing with these other ones. Now, do you guys remember exactly how I do the inverse cosine, the inverse tangent, and the inverse sine? What do we do for those? Yes, you have to press the second button, right? Because again, the inverse cosine is what's in green, and in order to access the green application, we have to press the green button first, obviously. So I'm going to go ahead and put in my decimal, 0.839, and then I press, if I want to take the inverse cosine, I press second cosine, and I get 32.97. Remember, 2 decimal places. The third number, if it's 5 or greater, that moves this digit up 1 more. So that's going to be 32.97. If I do the tangent of 12 divided by 15, I say divided on purpose because that's what we're doing with a fraction. 12 divided by 15 gives us that decimal. Then if we want to take the inverse tangent, we press second tangent, and we get 38.66. And then finally, for this one, if I want to take the inverse sine of that decimal, I type in the decimal first. Remember the pattern here with these, because these are the calculators that are actually allowed on the FSA, right? And the calculators that I assume we're going to let you borrow on the FSA. Who knows what's going to happen with COVID? But yeah, we got to make sure that we are familiar with this calc. I know some of you have a fancier calculator where you can, type in the function and put in the number inside and parentheses and all that. Those calculators, more likely than not, are not going to be allowed on the FSA. All right, so make sure that you are familiar with this calculator. So anyways, we're going to go ahead and put 0.423 second sine, and that gives us this decimal. So it's 25.02. All right, pretty straightforward. Really, the beginning of the test is just to make sure, just to reinforce some of the skills that you need to actually answer the true problems that we have to know how to do, right? So if I look at number 3, I have this triangle right here, triangle ABC, right? So who remembers what to do here? Yes.
You're gonna label the parts of the triangle based on the point of view of.
Yeah, let's look at the point of view from this angle that's right here inside of the triangle. We have 37 degrees. From the perspective of this angle, let's label our parts of the triangle. So I have,
Opposite.
yeah, opposite is which one?
That one that you.
Yeah, this AC right here, that's the opposite. Always like across from the angle is the opposite. Across from the 90 degrees is always the what? Hypotenuse. And then of course the one left over is adjacent. The adjacent is the one that people forget. But everyone remembers O and H, so just by process of elimination, we know that this is A. All right. And you don't have to, you don't always have to label all the parts of the triangle. You guys will get good enough at some point to be able to say, oh, we have A and H. Let's just jump into cosine. But for now, let's build up to that. So we know that we have something with the H. We have something with the A. O is over here by itself. So which trig function are we going to use that has A and H? Cosine, right? Cosine is the one that has A and H, and we know that cosine, and what goes inside of our cosine?
The angle.
The angle. So we have 37 degrees, right? And that's equal to adjacent over hypotenuse. So 11 over x. Oh, this is one of the annoying ones, right?
Yeah.
Where we have the x in the denominator, we have to do like that extra step to get x by itself, but that's fine. We practiced this enough. I think we should be experts on it. So again, we have cosine of 37. We're going to put that over 1, right? And then we're going to cross multiply. So we have x times cosine of 37, and that's equal to 11. All right? So in order to get x by itself here, what do we have to do?
You have to divide it by cosine.
Yeah, let's divide both sides by the cosine of 37, divided by the cosine of 37. Now, some of you are good enough, right, to where you can go ahead and just do this all in one step, right? We have 11 divided by 37 cosine. But the thing is, what's the one thing you guys always forget to do whenever we get to this part? Some of you always give me that answer as the decimal.
You need to divide it by.
No, yeah. Press the equal sign. That is your answer. 13.77. Okay? But just to kind of make sure that we don't make that mistake, I would rather you guys just write out the decimal, right? Let's just do 37 cosine is 0. Let's do 4 decimal places. 0.7986. So just write it out, 7986. Because I'm telling you right now, I've taught this long enough, and I know that every year there's always a student who forgets to press the equal sign. And that's usually half of my class. And I don't want half of you to get it wrong at the FSA. So let's just write out the decimal in BC. All right, so we have 11 divided by 0.7986 is equal to 13.77. And voila, there's our x value. All right, we're going to do the same thing for number 4, okay? So for number 4, again, from the perspective of 32 degrees, let's label the parts of our triangle. All right, across from our angle is which one again? That's the opposite. Across from the 90 degrees, hypotenuse. And then, of course, the one left over is the adjacent. All right. So now I look at my parts of the triangle and I say, okay, well, I know I have something with my O and I have something with my A. That's TOA, right? We're going to use tangent for this problem. All right. So I'm going to do tangent of 32 degrees. And that's equal to opposite over adjacent, x divided by 13. This is one of the nicer ones. Right? So again, just like what we always do, we're going to put this over 1, cross multiply. So x times 1 is just going to be x. 13 times tangent of 32. All right. I'm going to be strategic. I'm going to figure out what this decimal is first. Right? So 32 tangent gives me that decimal. I multiply that by 13. And I get 8.12. Let's stay consistent with 2 decimal places. 8.12. All right. I got a little blurry there for a second. Everyone good so far? We're good? Can move along? Perfect. All right. Ooh, this one's interesting. Now we have a theta inside. That's the symbol for theta. I know we're used to seeing x, but theta is the same thing. It's just an unknown variable, right? So if we have theta here, from the perspective of still our angle, it's no different, right? What are the different parts of the triangle that I'm going to go ahead and label? So across from theta is what? Opposite. The next one would be across from the 90-degree angle is our hypotenuse. And then, of course, last but not least, we have our adjacent. Okay. So now I go ahead and I say, okay, well, which parts of the triangle actually has something there? Adjacent has something there. The opposite has something there, right? O and A, we have TOA again, right? So we're going to go ahead and set it up as the tangent of, again, does it matter if this is a variable? No, it's still the angle. We're still putting our angle inside of our trig function. And that's going to be equal to the opposite over adjacent, 11.9 divided by 10. All right. Now, this one is different. If we have the unknown variable, in this case theta or x sometimes, if we have that inside of the trig function, what's the one thing different we're going to do with this? Angelus, what's the one thing different we're going to do with this one? Second, thank you. You guys are very quiet today. I know, you're probably like, oh, he's recording a video. Let's like be respectful. No, you still speak up, guys, all right? Jose doesn't shine. But anyway, so we have, we're going to go ahead and we're going to first figure out what our fraction is, our decimal. So we do 11.9 divided by 10. And we get 1.19, right? So again, if we want to get theta by itself, we essentially have to do the inverse tangent of this fraction, right? Good thing we practiced that earlier. So we want to do the inverse tangent. We're going to press second tangent, and we get 49.96. So theta is equal to 49.96. And there's our final answer. And guys, get in the habit of boxing your answers on the test. Sometimes some of you are messy. You just can't find your work. Not everyone, but whatever. All right. So now we're going to look at this triangle right here. Again, from the perspective of theta. Across from that, we have opposite. Across from 90 degrees, we have the hypotenuse. The one left over is our adjacent, right? Once we have everything labeled, it's pretty straightforward from there. I'm going to circle something there. I have something there. Opposite is all by itself. So we have A and H. Which string function are we going to use? Cosine. So we're going to do cosine of our unknown angle is equal to the adjacent 6 divided by the hypotenuse 9. Okay. So now if I want to get cosine by itself, I take the inverse. I should have put theta here. I'm going to take the inverse cosine of both sides, 6 over 9. So when I do the inverse cosine, first I'm going to figure out what my fraction is. 6 divided by 9 is that long decimal. And then to take the inverse cosine, I press second cosine. So I have theta is equal to 48.19. Perfect. Look at that. The front page of the review is all done. Now let's go to the back. So here we just want to, again, make sure that you really understand. You see how important SOHCAHTOA is, that one little phrase? Yeah. We really want to make sure you understand how to do this. So determine the following answers to the given triangle. Leave as a fraction and make sure that you simplify. Okay, some of you are horrible with fractions. I know fractions is like your worst nightmare since elementary school. But we can't avoid it. We got to learn how to simplify. So if I look at sine of C, all right, I'm going to look from the perspective of angle C, right? And what was that phrase again? SOHCAHTOA. So we know that the sine of this angle is going to be opposite over adjacent. No, opposite over hypotenuse. What am I saying? Sorry. So opposite of the angle C is which one? 16, right? And obviously our hypotenuse is going to be the same no matter what. So I'm just going to label this as h. But opposite of angle C is 16. So we're going to put 16 over, and then our hypotenuse is 34. Now, is that the simplified version of the fraction? No. What are they both divisible by? Really? 34 is divisible by 4? We get 34 divided by 4. We get a nice little, nope, we get a decimal. We don't want that, right? We know they're at least divisible by 2, right? They're both even numbers. So then 16 divided by 2 gives us 8. 34 divided by 2, 17. And then I don't think we can simplify that any further. So that's going to be the final answer there. 8 over 17. All right. I'm going to do the same thing with the cosine of A. Now, let me pick a different color here. I'm going to look from the perspective of angle A, right? What is the cosine of A? What's adjacent to angle A? Is it the 16th? Well, we already know that this is the hypotenuse, but which one is adjacent or next to angle A? 16. So, wow, we have the same thing. 16 divided by the hypotenuse is 34, so that reduces down to 8 over 17. Same answer. Don't get confused. Don't get tripped up by that. It's the same answer. Okay, I'm going to go back to angle C. It says if I want to know what is the cosine of angle C, well, again, cosine is the one that's next to angle C. Well, we already established that this was the opposite, so the one next to it is 30 divided by 34. We know they're both divisible by 2, right? So I'm going to divide both the top and the bottom by 2, so I get 15 over 17. There's my answer there. Should have given you guys more space. My bad. It's okay. I'm sure you'll forgive me. All right. And then going back to the perspective of angle A, I know that tangent is TOA, so opposite 30 divided by the adjacent 16. And so now I'm going to see if I can simplify this. Again, I know that they're at least divisible by 2, so let's start with that. I have 30 divided by 2 is 15. 16 divided by 2 is 8. Can I reduce that down any further? I know this is divisible by 3 and 5. This is only divisible by 4 and 2. Nope, I think that's about it. All right. And now for number 8.
Oh.
Do you guys remember how to even go about this one?
Subtract by 9.
Exactly. The cosine of this angle is the same exact thing as the sine of whatever this minus 90 is, right? So 90 minus 15, I can do that in my head, 75, right? So sine of 75 is equal to the cosine of 15. All right? Cosine of 48 is the same thing as sine of what?
42.
42. All right, this should be like shouldn't even take you a minute on the test, right? Just subtract 90 from the other number. So 90 minus 33 gives us, if I can even do that correctly, is 57. Wow. Call myself a math teacher. And then cosine of 9 degrees is the same thing as the sine of what? 81. Sine of 82 is the same thing as the cosine of 8. That should be very, very straightforward on the test, right? It's almost like I'm doing the whole test with you guys. And it's not even, still have like 20 minutes left in class. All right. Now for the word problem. So no, we hated math before, and now we include words in it. It's just even worse. All right. So it says from a point on the ground 12 feet from the base of a flagpole, the angle of elevation of the top of the pole measures 53 degrees. How tall is the flagpole? All right, so I'm going to draw a little flagpole. Brace yourselves for the most amazing piece of art you'll ever see. Little flagpole. America. All right. That was a horrible American flag, but whatever. So there's our flagpole. And it says that the angle of elevation, which you guys have to remember, with angle of elevation or angle of depression, this is what we talked about last week, right? You start from the horizontal, from a horizontal line, and if it's elevation, you start from the horizontal and you elevate it, okay? So it says from a point on the ground to here, the angle of elevation up to the top of the flagpole, so starting from the horizontal and elevating this way up 53 degrees, All right, we have 53 degrees right there. So it says 12 feet from the base of the flagpole. Okay, well, first of all, you can kind of like, just based off of the drawing, you already know that this is the 90-degree angle, right? So then it says 12 feet from the base of the flagpole. Where am I going to put the 12? It's going to be right here on the ground. So from this point to the base of the flagpole, that's 12. And they want to know how tall is the flagpole? So where am I going to put my X?
On the flagpole.
Yeah, this vertical line right there.
Okay.
And there you go. Now it's just a problem like we've been doing this whole time. I have this angle from the perspective of 53 degrees, right? What parts of the triangle do I have? Well, obviously the opposite is which one? That's X, right? Hypotenuse, that's the one across from the 90-degree angle. And then, of course, the one left over is adjacent. So I have TOA. So I'm going to set this up. Tangent of my angle, 53 degrees, is equal to opposite over adjacent, X divided by 12, right? And it's just more of the same. We're going to put this over 1, cross multiply. X times 1 is X. 12 times tangent of 53. That's what we're going to figure out right now. Thankfully, we have our calculator. So first, we'll do tangent of 53. I'm going to do angle 53. Tangent of that is, what is that? 1.33. And then this number times 12. I'll just do this all in one step. Times 12 equals 15.92. So X equals 15.92 feet. That's how tall the flagpole is. We should get in the habit of putting units there, right? 15.92 what? Feathers? Feet. Anyways, so if we look at number 10, from the top of a vertical cliff 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? Okay, well, I don't know how to draw a cliff, but I'll just draw a line like that, right? That's if I write cliff, that means that's what it is. See? All right. So here we know that that's the cliff. They say that there's an object. I don't know. Oh, 40 meters. So we know that the cliff is 40 meters high. The angle of depression of an object at the level of the cliff is 34 degrees. So I'll draw an object here, I guess. All right. How far is the object from the base of the cliff? So they want to know how far this object is from there. And they say that the angle of depression, again, this is where people get confused. Okay, and that's the angle of depression problems they're going to get you. All right. Again, you start from the top of the cliff. We're going to start this as our horizontal line, not vertical. Sorry. So then from the top of that cliff, the angle of depression, it's being depressed down, right? 34 degrees. So it's going down 34 degrees like that. It's depressing from the horizontal. And that's looking down at the object, right? But again, if you notice, we have our right triangle here, but our angle 34 degrees isn't even inside the triangle. Let's put it inside the triangle. Where am I going to put 34 degrees?
On the object.
Here or here?
On the object.
Close to where the object is, right? Again, because, and let me just remind you guys, we have parallel lines here. So if we have parallel lines cut by a transversal, this angle is the same as that angle. And let's see if you guys remember why. Why is that the same? What is the name of that special, those angle pairs? Jesus, you guys already forgot. Please. Yes, alternate interior angles. Yes. They're alternate interior angles. All right. And they want to know how far away this object is from the cliff. So I'm going to put X right there. Okay. Let me redraw my triangle here, because I mean, my drawing is as beautiful as it is. It's very distracting. So I'm going to put my little right triangle there, X there, 34 there, and 40 there. Perfect. Now this is a problem like all the ones we've been doing so far, right? So I'm going to label my triangle. From the perspective of 34 degrees, I have my opposite here. Hypotenuse is across from the 90-degree angle. Adjacent is there. OA again. All right. So I'm going to do tangent of 34 degrees is equal to opposite over adjacent, 40 divided by X. This is the annoying one. You're going to need to get X by itself by dividing later. But that's okay. We'll put this over 1 and cross multiply. So we have x times this is x times tangent of 34 is equal to 40 times 1 is 40. So to get x by itself, okay, luckily x is not inside, so we're just gonna, but to get it by itself, we divide both sides by the tangent of 34, divided by tangent of 34. Please don't get offended by this, but I don't trust you guys to put this in your calculator all in one go. I would rather you just write the decimal. X is equal to 40 divided by, let's write the decimal out here. So we have 34 tangent, and let's do 4 decimal places, 0.6745. And then let's just do it all in one go. 40, not 400, 40 divided by 0.6745 gives us 59.3. What is this, meters? Yeah, meters. Okay. And let's keep going. For number 11, it says Brian's kite is flying above a field at the end of 65 meters of string. God, there's always a kite problem in these things. So anyways, Brian's kite is flying above a field at the end of a 65-meter string. So here's Brian flying this beautiful looking, God, how do you draw those things? Whatever, it's a kite. That's a kite. And let's see, 65 meters of string. So this string has 65 meters to it. Let's see, Brian's so if the angle of elevation to the kite measures 70 degrees. So again, angle of elevation, we're starting from the horizontal and we're moving up. All right. Up, we have 70 degrees. All right. And then we want to know how far is this kite above Brian's head? We're just going to go ahead and assume, I think it's negligible any difference that we have here. So we're just going to go ahead and just say that this height right here is above Brian's head. So this is how far up we want to go. All right. And there you go. We have a perfect triangle that we can work with here. I don't need to redraw it. This is easy enough to see. So from the perspective of 70 degrees, opposite of that is x. Opposite of this, clearly what's 90 degrees is 65. So that's the hypotenuse. And then the one left over is adjacent. Finally, we have a sine function, right? Because if I circle what we have here, we know we have something there with the opposite. We have something there with the hypotenuse. Adjacent is by itself. So I know I'm going to use the sine of our angle 70 degrees. And that's equal to opposite over hypotenuse. X over 65. Put this over 1. X times 1 is x. 65 times the sine of 70. Let's do that real quickly. 70 sine times 65 gives us x is equal to 61.08. And there you go. That's the whole review. That's pretty much what the test is going to look like. All right, I'm going to go ahead and stop recording this video. Watch this 50 times if you have to, right? It'd be nice if everyone got 100 on the test. I know it's not going to happen, but that's okay. Some of you will, right? At least get close to it. So, and again, tomorrow I'm going to go ahead and make you another copy of a review very similar to this, okay? And then, of course, when you see the test, it's not going to be a surprise because you guys have all practiced an adequate amount, and you should be good. All right, so I'm going to go ahead and stop recording this video. I stop recording. And good luck.